Good morning, ladies and gentlemen. Today I shall demonstrate some functionality of the MapMagic plugin that I wrote. Now, imagine that we wish to make a more diverse forest. In our example, our terrain is simply flat, and our forest is fairly simple too, consisting of a scatter node, a forest node, and then we split up the forest trees by scale into 3 different prefabs. However, what if we wanted to use more prefabs, or wanted to have different patches of forest coexisting within the same terrain? How would we do that? Well, to do this, we can use some functionality added by the GEMM plugin. Now, allow me to bring up my Voronoi noise and to just show you why I like using Voronoi for this specific case. But first, let's clear the trees out. Now, I found that using flat Voronoi with a fairly high intensity and small cell count produces this pattern, which is kind of conducive to having different patches of trees. However, to obtain something interesting, let's say we wish to make 2 separate forests, we can use one of the new additions, the slice node, to take the noise mask and to effectively convert it, separating it to 2 binary masks of lower and upper frequencies effectively. Now, the resulting pattern should be fairly interesting for this example at the very least. Now, with these 2 patterns, we would like to separate the forest into 2 separate forests, right? But without duplicating the actual forest node so that we don't have to do the computation twice. So for this, we can use the new stratify node, which allows you to separate any sort of object hash given a set of masks. And obviously, the stronger the mask in a given area, the object will be placed in that resulting set. Read the docs, really. It's much better explained there. Now, these separate masks can then be fed into a multiplexer, or a mux, which can take them in and process them simultaneously. Now, muxing is something very useful, which I found lacking in the regular MapMagic, although MapMagic is a fantastic framework, I do have to say that. Now, the mux is connected to a demux, multiplexer to a demultiplexer naturally, and within these 2 nodes we can do whatever we want. Now, we're only going to have a single split node, so we need to have the demux take in 3 objects per layer, and our 2 forests are an individual layer each in the mux, meaning that we also have 2 output layers. And now we feed the split nodes through the mux, and let's show an example that the first mask, or the first forest, is now masked only according to the input that we fed it into. Let's add the prefab back again, and you can see that the free area is in the exact location where the second mask would be, meaning that the forest is only spawned wherever the mask is going to be. And setting it to propagate in this case, it doesn't really help, so let's leave it at that. Now, if we connect the second layer, we can see that the second forest, but I have to bring this back up into place. The second forest is produced. The trees are placed at the same spots where the first forest, where the regular forest trees, I have to say, would be placed, but they are separate. And this allows you to effectively create different patches of trees, or, you can use a different sort of noise and make whatever you want, really, but it allows you to diversify things. And if we wish to make even more diverse forests, we can use the varying trees output instead of the trees output. This is exactly the same, except that, as you can see, you may add more than 1 prefab to every tree layer. And this allows you to, instead of just using one sort of tree, you can use multiple types of trees. And you can see me here overriding the wrong tree prefab, but that's always fun. And now, if we connect this, but allow me to set up a few prefabs first, 2 for the small, 2 for the medium ones, and I left the large ones with just a single prefab, since, for the sake of example, nothing much is really needed. None entries that are unlinked to a prefab will be ignored in the output. And after having set up our prefabs, we can just feed in one of the layers for the sake of example, let's say the small ones. examine now how the trees, even though we've only input what's effectively a small trees and half the mask, the trees are still different. And if we remove one of the prefabs in this case, then all the trees will revert back to an individual one. And this obviously allows you, well, to, if you'd use trees that look different but still fairly similar, at least that's what I would do in a real case scenario, this will allow you to dramatically diversify your forest without having tons and tons of tree outputs or nodes or, just having different things. And this node also exposes the variance for tree colors that Unity allows us, but it doesn't work on my prefabs because they've added, well, they have LODs, and Unity trees and trees on Unity terrains had some issues with some things. And now obviously if we add other prefabs here, the forest can become much more interesting in general. And I'm not going to do this for the second layer because it's too much work, but you get the point. And well, it's something that was lacking in MapMagic, and I also found it useful, and there's a corresponding output for objects as well. Since you don't need to scatter one single rock, you can scatter multiple different rocks with the same exact properties. Now, something else I wanted to show you aside from some of the other stuff that we add is the scaling Voronoi node, which is right in the middle there, but I don't see it in this case. There we go. And so one of the issues I have with Voronoi is that we can't really regulate how large these patches are, right? We can only fiddle with the cell count. But what if I want a cell count of 4 because I like the shapes and I also like my patches to be bigger? Well, for this we can use the new scaling Voronoi node, which if we leave the scale factor at 1 and we replicate the properties, it's going to look exactly the same as the normal one. However, if we bump up the scale factor to 2, the patches grow larger and we can tweak their magnitude with amplification, but in this case we really don't wish to disable amplification. And well, if we now link these larger noise patches to the forest input, you can see that the actual forests, well, the first half of the forest, since remember we never connected the second layer of the demuxed output, is the same, and you can also make them smaller if you wish. And that way you can actually tweak the size of the Voronoi noise that you produce, which should be useful, right? At least I found it useful. That's why I wrote it in. And that's pretty much it. You can do whatever you want. You can have multiple nodes inside the mux. Look at the examples, read the docs. Thank you very much for watching, and happy MapMagicking.